Can't happen. And why not?
Because it's lower than iron.
Good. No reaction. So Sn is lower. And Fe on the activity series. Okay, so we get no reaction.
Can you go back up to the first one after?
Yep.
So, that'd be a problem with our test groups, that's totally right.
So, well, the one you would write no reaction, like before. Now, if there is a reaction, we're going to go through the same process we did yesterday. So this is going to, like I said, it's going to kind of reinforce the same thing over and over again. So let's look at one where we have to do everything. Everybody good here?
So what's the one above that one? No reaction, just.
No reaction is just no reaction.
No, the reaction one, which.
Now the reaction one, if there's a reaction, you got work to do.
So you're just doing it below.
Yeah, I'm just saying, trying to show how the activity series work.
Okay.
So let's say now, if there is a reaction, then you need to write out the, what do we want to make sure we call it the same thing, a balanced chemical equation. Chemical equation. The total ionic equation. And the net ionic equation. So again, it's the same exact process as we did before. The major difference is this. In order to determine if there's a reaction, you're either going to look to the solubility rules if it's double replacement precipitation, or you can look to the activity series if it's a single replacement. So how you get started, look at two different lists. Okay, so let's say, okay, so we're going to start out one, balanced, less chemical equation. This is just a regular old equation. Let's say we got Cu solid with AgNO3 aqueous. So those are the two things that are reacting. So copper solid plus AgNO3 AQ. What's replacing what? Peter?
Cu with Ag.
Okay, so Cu is trying to replace Ag. And if we go to our activity series here, I'm going to scroll up here. Can copper replace silver? Mm-hmm. Yep, it's immediately above it, so it can't replace it. Now, just another thing to note. Copper has multiple charges if you go look at the periodic table. It could be +1 or +2. But we can cheat here. What are we going to call it? +2. See that? So we can kind of cheat a little bit for some of these. So when you're looking for charges for these things and these reactions, sometimes it's better just to go to this sheet first and see if they specify. If not, then you have to go to your periodic table and figure it out. So let's try and do whatever's easiest first. Okay, so these are trying to replace each other. And just move this a little bit. Okay, so, all right, so that's trying to replace that. So it can happen. So that means I'm going to get a new set of products. Yeah?
Does the charge of the metal matter?
Yes. Okay, here's why it matters. Because right now, silver is going to come out of solution. So think about it like this. If I throw in, and I should do this for you. Actually, I got a demo I can do for you. What I'll do is I'll take, any of you guys running the turkey trot? Okay, you know how you get a little chip? A lot of you guys know about that. You get a little chip you tie it to your shoe. I'll cut one of those open, and basically what's in there is a little transistor of sorts. It's called an RFID, and there's a big coil of copper. It's just a big coil of copper, and so when you run over it, the starting line goes into that copper and conducts a current, and that current tells that chip to send out a little signal, which the computer says, okay, that's Brian Markley. He just ran across the line. But I'll take a chunk of that, and I'll throw it into that silver nitrate. And what's going to happen is that copper is going to dissolve in this solution. And what's going to happen is silver particles are going to come out of solution and fall to the bottom. Right? So they're trading places in the solution. The copper is replacing the silver in the solution. So silver is going to come out of solution, but in order to get my products, I have to crisscross the things that are left over. So crisscross, I got to crisscross Cu with NO3. NO3 is a negative from our polyatomic ion sheet. Copper, we're cheating to find out that it's +2. Because there's no way for me to tell by just looking at this which charge it would be. Because it's not bound up with anything else, I don't know. So when I crisscross this, I get Cu parentheses NO3 parentheses 2. And this is going to be aqueous, always. Now I got a balancing problem here. My nitrates are out of balance, so I'm going to balance up my nitrates by putting a 2 in front of silver nitrate. And that just screwed up my silvers, so now I'm going to put a 2 in front of silver. So now I'm balanced. Don't take shortcuts, write down your charges. So that's basically the same thing we did yesterday, only difference is instead of having aqueous, aqueous, solid aqueous, I have solid aqueous, solid aqueous. I have not two things and two things, I've got one thing and one thing. All right, so my second equation is my total ionic equation. So here's where I take everything that's aqueous and I rip it apart. If it's not aqueous, leave it alone. So my copper just comes down because it's not aqueous. And then I'm going to split up into, there's 4 things I got to split. When I split something up, there's 4 things. There's the symbols, so Ag and NO3, the charges, nitrates, -1. If you looked up silver, you'd find out it's +1. It's only the state that it has. That's 2 things. How many of each? I've got 2 of each. That's 3 things. And then the state AQ for both of these. So when I break stuff up, 4 things: symbol, charge, coefficient, state. And that reacts to form 2 silvers, which are solid, plus 4 things, okay? Copper and nitrate. Charges are -1 and +2 because I already looked them up. I have 1 copper, so I don't use a coefficient. I have 2 nitrates, that's 2. And the states are AQ. AQ. So that's my total ionic. 3, my net ionic. What do I do with my net ionic? I gotta identify the ones that don't. The things that stay.
Is it just
Spectators, yes. Things that stay the same. So net ionic equation. Okay, so if I look here, I've got nitrate as a spectator. Spectators. So if you notice here, before we got 2 sets of spectator ions, now here we only get 1 spectator. Spectators ion, that sounds stupid. Okay, so now we take that out of the equation. So basically I'm going to write down what exactly happened. What exactly happened? Copper, solid, got together with 2 Ag plus aqueous, and they traded places. So this 2 Ag precipitated out of solution, became a solid, and copper plus 2 dissolved. Because if it was charged, that means water would be forming around, it means it would be dissolved. So when it's not charged, it's not dissolved, it's a solid, and when it is charged, then it's in a dissolved state. So let me do this.
So to do all three of those every time it has a reaction?
Every time there has a reaction, yeah.
So the metals on the right side, like if they're reacting with another to become aqueous solution, they'll have a charge on the right?
Anything that's aqueous is gonna have a charge, anything that's solid is not. Is that a way to answer it? Okay. All right, so far, you already now have 4/5 of the next test. All right? There's gonna be 2 possible precipitation, one's gonna be a no reaction. You have 2 single replacements, and one's possibly gonna be, or one is going to be a no reaction, right? So far, it's not as bad as it sounds, is it? It should sound a little better. Okay, so let's see. Did I freeze this? Whoops. I want to freeze that for a second so I can get this done. Let's see. This, this. Okay. Okay, so I guess that doesn't fit on there too nicely, so maybe I'll just leave this here for a second like this. So up here, you got last night's homework, and if you remember, we went through 38 already and found out, remember that these are, everything's aqueous, no reaction? And this, everything was aqueous, no reaction? This one we found there was a reaction because when Mg got together with CO3, the rule said all carbonates form insoluble compounds except groups 1A and NH4. Well, that's not Na, or that's not group 1A and that's not NH4, so this is not an exception. It follows the rule, something is insoluble, you get a solvent. So what I'm gonna do is, I'll take you through this one and then we'll have you guys do the other one. Does that sound like a deal?
The other one is in deal.
What's that?
Deal.
Deal, good. Sold. All right, so this one says, so this is 38/40C, because the directions say, if there, it says, 38 says, determine if there is a precipitate that forms. 40 says, if a precipitate forms, then write a balanced molecular equation, a total ionic, and a net ionic equation. So I'm gonna go through and do the whole deal. So this I have, potassium carbonate, K2CO3, aqueous, reacting with magnesium iodide. Magnesium iodide. And that's aqueous.